Out there in the endless dark, the universe keeps its secrets. But sometimes, the unknown calls to us, loud and clear, a signal from another galaxy. And what we found changes everything. Coming from the Andromeda Galaxy, over 2.5 million light-years away. When physicist Dr. Michio Kaku announced this, the scientific community, and honestly the whole world, lit up with excitement. Here's what makes this signal so wild. It's precise, repeating, and nothing like the usual cosmic noise from pulsars or black holes. At first people thought it was just a mistake with the telescope, but after multiple checks the signal held up. It's real and it's coming from a quiet spot in Andromeda, not some hotbed of star formation or exotic cosmic event. Even weirder, the area glows intensely in infrared, possibly hinting at some massive structure, like a Dyson sphere, built to harness energy from a star. What does this mean? The signal could be artificial. Experts say it would take a civilization at least as advanced as a Type 2 on the Kardashev scale to pull this off, meaning a group that can control the energy of an entire star. And the signal seems to contain patterns, maybe information, maybe even a message, encoded in ways we're just starting to decode. This discovery has scientists, linguists, AI experts, and even philosophers working together to figure out what's going on. Around the globe, observatories are teaming up, and a new initiative called Project Andromeda is inviting everyone, even citizen scientists, to join the search. The big question: is this a deliberate message, a beacon, or something else entirely? Should humanity try to answer? For now, all I know is the universe feels a lot more alive, and the search for meaning just got a whole lot more interesting. In the silent darkness beyond Earth, a golden marvel awakens, unfolding its wings to the cosmos, shimmering with the promise of discovery. This is not just a telescope, it is humanity's boldest leap into the unknown. Suspended 1 million miles from home, the James Webb Space Telescope, JWST, floats as a sentinel at the edge of forever, its golden mirrors catching the faintest whispers of ancient starlight. Crafted with impossible precision, it is the most powerful observatory ever built, a gateway through which we peer into the deepest mysteries of the universe. Webb is designed to look back in time, to the universe's first dawn, witnessing the birth of stars and galaxies just after the Big Bang. Unlike Hubble, which sees the universe in visible light, Webb's vision pierces the invisible, capturing the glow of creation itself in infrared. Its infrared eyes cut through cosmic dust, unveiling hidden stars, galaxies, and the secrets of the universe's past. The massive gold-coated mirror, over 21 feet across, captures the faintest echoes of light, signals that have traveled billions of years to reach us. To achieve this, Webb must remain colder than the coldest places on Earth, shielded by a 5-layer sunshield the size of a tennis court, an engineering marvel unfolding in the void. Its mission? To illuminate the universe's first moments, to witness the birth of stars and planets, and to reveal the drama of cosmic creation. Webb is not just a machine, it is a time machine, a cosmic gateway, and a symbol of our relentless curiosity. It stands as a testament to what humanity can achieve when we dare to ask what lies beyond. Our nearest major galactic neighbor, the Andromeda Galaxy, is a breathtaking spiral galaxy even larger than the Milky Way. Located 2.5 million light-years away, it's the most distant object visible to the naked eye. Andromeda contains over 1 trillion stars, making it a stellar metropolis and an irresistible target for astronomers. Its proximity lets us study its structure, star clusters, and central black hole, offering insights into our own galaxy's past and future. Andromeda is also on a collision course with the Milky Way, set to merge in about 4.5 billion years. The James Webb Space Telescope's infrared vision pierces Andromeda's dust, revealing hidden star nurseries and analyzing the chemical makeup of its oldest stars. By mapping Andromeda in unprecedented detail, Webb helps us compare it to the Milky Way and refine our theories of galactic evolution. This high-definition portrait brings us closer to understanding the ultimate fate of our cosmic neighborhood. While mapping star-forming regions in Andromeda, the James Webb Space Telescope detected something unexpected. A faint, persistent signal. This wasn't the usual cosmic noise, it was a narrowband emission, a sharp spike in the data, unlike natural phenomena. At first, scientists suspected a glitch, but repeated checks confirmed the signal was real and coming from the same spot. The source, a quiet dark patch between Andromeda's spiral arms, an unlikely place for such a structured signal. Natural signals usually come from energetic environments, not calm regions like this. Months of verification ruled out instrument error and Earth-based interference. The signal was a genuine cosmic mystery, not fitting any known astrophysical model. Its energy was highly organized, efficiently converted into a specific infrared frequency. What began as a routine survey had become a cosmic detective story. The universe had just handed scientists a puzzle unlike any before. What makes the Andromeda signal so electrifying is its narrowband nature. Almost all its energy is focused at a single frequency, unlike the broad emissions of stars or nebulae. Such precision is rare in nature and usually signals something artificial. While some natural phenomena like cosmic masers can produce narrowband signals, this one didn't match any known profiles. Even more intriguing, the signal contained faint, repeating patterns, complex modulations, not seen in random cosmic noise. Natural signals tend to be chaotic or follow simple cycles. This one suggested intentional structure. On Earth, all our communication systems use narrowband modulated signals to transmit information. The Andromeda signal shares these hallmarks, raising the possibility of an engineered origin. Scientists remain cautious, but the signal's characteristics are hard to dismiss as a cosmic coincidence. It's a discovery that blurs the line between natural wonder and technological artifact. The scientific community is buzzing with excitement and skepticism in equal measure. When news of the potential Andromeda signal broke, sending ripples of excitement and disbelief across the globe, the world naturally turned to physicists like myself for perspective, seeking some clarity amidst the extraordinary claims. My immediate reaction was one of cautious exhilaration, a potent mix of scientific intrigue and measured skepticism. The universe, as we've learned time and again, often defies our preconceived notions and expectations, and this perplexing signal emanating from so far away is a prime example of the universe's capacity to surprise us. Its characteristics, particularly its narrow-band nature and complex modulation, align precisely with what SETI researchers have been diligently seeking for decades. A compelling candidate signal of significant interest, warranting intense scrutiny. Of course, we must rigorously exhaust all potential natural explanations before jumping to any conclusions, but the initial data appears remarkably robust, showing a consistency that is hard to dismiss. And the artificial-like features embedded within the signal are proving particularly difficult to ignore or explain away through natural phenomena. The sheer amount of energy that would be needed to generate and transmit such a signal across the immense gulf of millions of light-years separating us from Andromeda strongly suggests a civilization possessing capabilities far, far beyond our own current technological level, perhaps even approaching or having surpassed a Type II classification on the Kardashev scale of technological advancement. If indeed artificial in origin, this momentous discovery could represent our very first confirmed glimpse of a truly advanced extraterrestrial society, one capable of harnessing stellar-scale technology and engineering feats beyond our current comprehension. The big fundamental questions immediately follow. Is this a deliberately constructed message, a beacon intended for others to find, or are we simply eavesdropping, inadvertently intercepting their routine communications or technological processes? Genuine contact with such a vastly advanced civilization holds the potential to fundamentally transform humanity and our understanding of the cosmos. But it could also pose unforeseen risks and challenges that we cannot yet fully imagine or prepare for. For the time being, our primary course of action must be to listen intently, to study the signal with meticulous care, and to proceed in our investigations with a balanced approach of both unbridled curiosity and utmost caution. The long-held silence of the universe, the cosmic quiet we've always known, may have just been irrevocably broken. The potential implications of this discovery are truly staggering, promising a paradigm shift in our understanding of life beyond Earth. Beyond the possibility of alien intelligence, this signal challenges our understanding of galaxy evolution and star formation. It comes from a region thought to be quiet, where little star birth occurs. Our models say such areas should be silent, yet here's a powerful, organized energy source. Could this be a new kind of stellar remnant or unknown natural process? If so, it would rewrite our textbooks and expand our search for habitable worlds to unexpected places. It suggests complex phenomena, and maybe life could arise in more cosmic settings than we imagined. This discovery urges us to look beyond the brightest objects and pay attention to the universe's quiet corners. Sometimes the greatest secrets hide in plain sight. The structured signal from Andromeda forces us to confront the question, are we alone? If artificial, it's the first evidence of intelligence beyond Earth, a turning point for humanity. Is it a deliberate beacon, a "we are here" message, or are we eavesdropping on their technology? The signal's complexity could be a primer, a cosmic Rosetta Stone, meant to establish communication. Or perhaps it's just a byproduct of their daily life, like us overhearing distant radio chatter. Either way, it's humbling to realize we might be witnessing the work of a civilization so advanced its signals cross galaxies. The discovery energizes the search for life, shifting it from speculation to active investigation. For the first time, we're not just listening for a reply, we're examining a real, mysterious whisper from the stars. The unexpected detection of this anomalous signal has significantly reshaped the James Webb Space Telescope's observational priorities. What was once a broad survey of the cosmos has now been laser-focused on understanding the nature of this intriguing phenomenon. Webb will now dedicate a significant portion of its observing time to long-term, detailed observations of the signal's source. This extended scrutiny is crucial for gathering enough data to characterize the signal accurately. It will employ deep-field infrared spectroscopy, a powerful technique, to meticulously analyze the signal's properties, including its spectral composition and energy distribution. This will help determine the source's temperature, density, and chemical makeup. This endeavor is not confined to a single telescope or nation, it's a global effort. Radio telescopes and X-ray observatories, both on Earth and in orbit, will join in the coordinated observation campaign, searching for related signals across the entire electromagnetic spectrum. This multi-pronged approach increases the chances of detecting any accompanying emissions. By combining data from these diverse instruments, scientists from around the world hope to construct a complete and detailed profile of the source, piecing together the puzzle of its origin and characteristics. Ultimately, the goal is to determine its true nature, whether it's a previously unknown astrophysical object or something entirely unexpected. The discovery also fundamentally changes how we approach the search for similar signals emanating from other galaxies, expanding our search parameters. Webb's advanced instruments will now be programmed to automatically flag any comparable anomalies during its routine surveys, acting as a cosmic tripwire. If more signals of this kind are found, we could potentially map their distribution across the cosmos and study them collectively as a new and previously unrecognized class of cosmic phenomena, opening up entirely new avenues of research. The investigation will undoubtedly be a slow and meticulous process. The signal we've detected has been traveling for millions of years, a relic of a distant past, and therefore any potential response from the source, should it exist, would take just as long to arrive, spanning vast stretches of cosmic time. However, the real and lasting value of this investigation lies in what it can ultimately teach us about the fundamental nature of the universe, and perhaps more profoundly, about humanity's place within the grand cosmic tapestry. Patient, persistent, and cutting-edge science, combined with international collaboration, will be absolutely key to unraveling this profound and potentially paradigm-shifting mystery. The detection of this signal marks a pivotal moment in science. It shatters our complacency and reminds us how mysterious the universe truly is. If it's a new astrophysical phenomenon, it will open an entirely new field of study and force us to rewrite our understanding of the cosmos. If it's artificial, it answers the age-old question, are we alone? Such a discovery would transform our perspective on life, religion, and our future as a species. Either way, this whisper from Andromeda is a catalyst for curiosity and wonder. The James Webb Space Telescope was built to explore the universe's origins, and may have given us a glimpse of its future. Whether it's a new law of physics or the echo of distant intelligence, a new chapter in our cosmic story has begun. The story is far from over,